Ever since one of my first recordings, I hinted at the use of EVPN inside NSXT as a 3.0 release item. So I've been asked to dig into this a bit deeper by a couple of my customers in some whiteboarding sessions. So I thought I'd record this session for everybody to have a look at. If there's any questions, please let me know. This is be a high-level overview of BGP-based EVPN and NSXT. So the way that this works inside NSXT is we have a tier 0 router, just like we do for any other external connectivity. So my tier 0 router here is called peering. So no surprise what this tier 0 is doing. This is connecting to a Juniper Mx router as my upstream BGP peer, and I'm exchanging EVPN routes with this device. So there's an address on here. And an address on the MX as well. And we'll go through and we'll validate the configuration of the tier 0 and make some additional changes to it if we need to enable it for EVPN support. Let's go through and have a look at the NSXT manager. So I've got my peering tier 0 router here. So look at the configuration of it. Have a look at a couple of things to be aware of as well. Okay, it's called peering. Fantastic. Nothing needs to be set under the additional settings. The route distinguisher, we need to ensure we have a route distinguisher for advertisement of EVPN routes. Essentially, this would be a loopback address on a physical routing platform. So treat this as you would a unique loopback address for each tier 0. Leave the default EVPN settings alone. I've got an interface configuration here that is talking to my external network. So I've actually got 2 addresses on there. I'm just using one for my peering. And routing is configured. That's all defaults. Route redistribution is enabled as well. So just like a real router, make sure you're actually configured which routes you want to be advertised upstream. Default BGP configuration knobs, my local AS is 65,000. Same BGP AS is configured on my neighbors, so essentially iBGP. My one MX router here as well is configured remote AS number, same as mine. Addressing is configured. And the most important thing here under route filter is to make sure you've enabled layer 2 VPN for EVPN address family, and I have IPv4 configured as well. So we'll jump back onto the MX and just verify our configuration for BGP on this side. So as you can see, looking at the configuration, my local address, what should be 221, not here it is. I've actually got 2 peering sessions. Now the important thing is I'm actually advertising and receiving IPv4 routes and EVPN routes that negotiate these 2 address families. And I have currently received no BGP routes. I have received some IPv4 routes. So I've an established BGP session with my tier 0 peering instance. So we need to get some routes into this EVPN section now as well. So we do that through the NSXT manager. Adding a VRF or an EVPN instance is essentially another tier 0 gateway, but it's a VRF. So select a VRF, give it a name, I'll call it customer A, and I will connect that to my peering instance. I need to configure the VRF settings for this. So the route distinguisher will be the IP address and a unique number for this routing instance. I'm going to use a VXLAN VNI of 79,001. My route targets essentially the rules around which community tags I will use to import and export routes. So I will import any route I'm received that has a tag of 65,100, and I'll export my routes with the same number. Radio, and save this configuration. And I need to configure a few more things here as well. So we need to make sure that our rate resolution is configured. Okay, that's fine. The allowed rate resolution, that's the only thing that has to be configured here. So close that. Let's jump back into our diagram. So what we've done now is we've configured a VRF that's sitting directly inside our our peering T0. So it's in here. And I've given it the number of our route distinguishers and route targets, so what we're using to differentiate between routes. I need to now configure the same configuration down here on the routing side. So when we exchange routes back and forward, using our route targets and our route distinguisher, they'll be dropped into the correct instance. I won't go too deep on the difference between these two things here. It's pretty well documented. Right, let's have a look at the MX side of things. So the configuration we would need from the CLI would be this configuration here. So I'm going to add a new routing instance called customer A. I'm going to basically tell it to use VXLAN as my overlay and use the same VNI I've configured on the NSX side. So type VRF, and then my route distinguishers as well. So my loopback address and my target. So I'm going to accept the same routes as well. So the VRF target will allow me to import and export routes using the same number. Right, so now we're configured. So we still have not received any routes from the NSX side of things because we don't have any segments configured. So we'll jump back onto the NSX side of things. We've got our VRF now sitting inside our peering router. We'll make a tier 1 router as well. We'll like customer tier 1. We're going to connect this to customer A VRF. We have to configure the edge cluster it's using and save that. And we'll go back and reconfigure a few things here as well. So it's important that we have route advertisement configured as well. So we need to make sure we're advertising our connected segments. We need to configure our DHCP server as well. And save that. So now we've actually configured a dedicated tenancy for this customer. And we plugged it into the VRF. And this is our tier 1. And to this we need to connect a segment. So let's go in here and we'll create a new network segment. Customer A servers. We're going to plug that into the tier 1 customer A. We're going to use an overlay network. We're going to allocate some addresses for them. Or let's configure DHCP as well, turn that on. 77.10. Let's do this allocation as well, apply that, and that's all we need to do. So I've now configured and 77.1 is my default gateway, and we're allocating addresses from 10 to 100 up here for any workloads that are attached to that network segment. So we can jump back onto the MX now and see if anything's changed, and nothing has changed. So we do not have any routes here yet. We're not seeing the 192.168.177 network appearing in here. This is because we don't have any workloads actually attached to that network segment. So we'll come back onto here. I've got this web server here. Let's attach him to the customer A network segment. Select that to turn it on as well. So boot that up. Let this machine boot up and it should request an IP address through DHCP from the distributed DHCP server built into the tier 1 routing platform. Okay, so it's received the first IP address, 192.168.177.10. 177.10. Let's see if we have that on our, okay. Okay, why isn't it advertising it? Let's have a look and see what's going on the MX side of things. Sorry, on the NSXT manager. So we've configured the machine. We're seeing an IP address on the server. We can probably ping our gateway. That's a security policy, so let's look at our security. Okay, so we had a firewall sitting in line, blocking our ICMP packet. Right, so we're not receiving any routes. Okay, let's have a closer look at this. So the important thing to look at when we start going into this type of situation is really looking at route redistribution. Our peering router here, we're telling it what routes to advertise. So I've got a policy here that says connected interfaces and subnets from tier 1. So yes, that's good. Close that. Let's move up into our VRF now as well. Okay. Oh, I have no policy here for this, so no subnets. Right, so we're going to tell it in here we really want to advertise our tier 1 subnets. Take this for good measure as well. So as you can see, by default, NSXT won't be advertising connected interfaces, static routes, up to upstream peers. We have to go through and actually configure this like we would on another routing platform. It's time to actually go through and do that. What is that? Right, there we go. So NSXT won't advertise routes unless there is actually a segment with active workloads on it, and it won't advertise any routes, connected interfaces, static routes, etc., unless the tick box is actually configured as well. Right, as you can see, we have received 192.168.177.0/24. This has been received as an EVPN type 5 route. So there's some neat things that come along for the ride with a type 5 route. Single route is advertised to our peering neighbors, along with the target communities where we've attached to the route. We actually advertise the encapsulation type we wish to use as well, and where the upstream MAC address is to actually send the tunnel to. So this is default behavior. We're expecting that we will have VXLAN encapsulation from the peering router through to the tier 0 router. We're advertising our VNI to the upstream device as well, so we know when we encapsulate the traffic inside this EVPN instance, we need to actually identify the traffic as being belonging to that VNI as well. Right, so it's much the same process to go through and add an additional device as well. So if we configure another routing instance, we call this customer B. So I've added a second peer as well to this, using a different route distinguisher, which we have to have if there's a potentially overlapping address space. Our route target is different, and our VNI is different as well. So let's go through and configure this quickly inside here as well. So I'll add another VRF. We'll call this one customer B. We're going to connect that to peering router. We'll save that. We'll go back into configuration, set the DHCP configuration. Actually, we don't need to do that here. We'll do that from the, okay, so this can all remain the same. Like that. Make sure we don't make the same mistake as last time. We're going to advertise our rates. Like that, that. Save that. So now I've configured another customer. This out here. This will be using route distinguishers, maybe 200. The same, we reuse the same number for our route targets as well, although you don't have to. And we've already configured this. So you can quickly configure this. So we'll configure a tier 1 and a tier 1 gateway. Plug it into there. Make sure it's configured for this. Save. Come back. This is when you configure our DHCP server. You should always configure it in the tier 1 gateway these days, so we have distributed DHCP functions. Advertise my connected routes upstream. Close that. All right, add a segment. Yep. Customer, the servers. That's going to be plugged into the tier 1. So we're using overlay. Let's see if we can use the same address space. Turn the DHCP server on. Well, enable it. 77.10. So we have customer A servers, customer B servers, both using the same subnet. Let's bring up our second web server. Drop into the customer B server network and power that up. There we go. This has got the same IP address. So the two servers, the same IP addresses. So and the same address space being advertised here. I've got one workload attached. Right, let's go down and have a look at our MX down here as well. Oh, I think I've forgotten to put something. Probably the most important things. So this is actually good to go through and actually show how these things can be broken if not configured properly. So I need to configure my route distinguisher, my route targets. So routes won't be advertised or imported unless they're configured. Like that. So I've got this configured and also my BNI too. Save that. Oh, typo. Right. That's it. So customer A, customer B. Okay, link segments. Okay. Yeah, now that worked. So I now have two separate routing tables. Customer A and B. They both have exactly the same route. So what's the difference between them? Right, so we'll see that this target here, actually more importantly, the route distinguisher. So we'll actually see that we have overlapping address space. We are advertising the exact same route, but the difference really is that route distinguishing. and we'll go back and look at customer B as well. Right, so this is the great thing about EVPN. Overlapping address space doesn't matter. We drop it into completely separate, discrete routing tables, advertise it to our peers using a locally or globally significant route distinguisher, which they use to isolate the traffic into separate routing tables. And we forward traffic between each other using a separate VNI number as well. So just draw that on the diagram just to be clear as well. So this was using 79002, 79001. So the encapsulated traffic actually is uniquely identified as well. So when it hits the upstream router, it can be de-encapsulated and dropped into the correct EVPN VRF for forwarding. Right, and that is BGP-based EVPN on NSX. If you have any questions about how to configure this inside NSX, or if you need guidance on how to actually configure this to your upstream routing platform, please let me know. Happy to help out. Thank you. Have a good day. Bye.